Intersections are really a treasure trove of data, both from the intersection infrastructure itself and from all the vehicles, bikes, peds, and scooters traveling through it. At the intersection, data is created from sensors, from controllers, from apps and software connected to either one. Other external sources include connected automated vehicles, the Internet of Things, probe data, and the growing sources of new companies such as Waze and Streetlight and many others. The cloud also plays an important role in storing data. The data can be real-time, streaming, or stored over time. The value really comes in combining all the data in meaningful ways. So let's set the stage by talking about the types of data we can actually extract from intersections. They fall under three main categories. First is usage. How many vehicles, people, bikes, scooters, etc. are using the intersection? The second deals with operation. How well are those vehicles traveling through the intersection, both from a mobility standpoint and, more importantly, from a safety standpoint? Geometry is the third area, and here we look at what design elements look like. Together, all three of these lead to performance measures that qualify and quantify efficiency, mobility, and safety at the intersection. So first of all, the first area in usage, we take a look at what type of data we can extract from the intersection regarding usage. We can look at things like number and types of vehicles, such as bikes and pedestrians, traffic by classification. We can see how many and whether buses, trucks, and other vehicles are traveling through the intersection. We can extract volumes, either through turning movements and through. We could look at annual average daily traffic. We can look at speeds, how quickly, either point speeds or corridor speeds. We have distance, then we can start to look at travel time through an arterial along a network. We can also look at the location of vehicles within the intersection, and we're starting to get better at looking at trajectories, how those vehicles are traveling through the intersection and how they relate to each other, which leads to the ability to look at things like near-miss analysis. In the second category, around operation, we get a lot of data on things like signal timing and phasing. We talked about that SPAT data. We can look at signal cycle length, green time, and I'm going to go into that into a lot more detail in a few slides. We can look at uptime, whether the equipment is up or down and needs to be repaired. We can look at events at the intersection. As we know, each controller event is logged with an intersection number, timestamp, an event code, and a parameter. And I'll go into a little more detail on how we use those events and those event codes and parameters to actually track what's happening at the intersection. In the third area, under geometry, the first thing that we're looking at is the type of intersection. So is it a continuous flow intersection, a divergent diamond, continuous green T-section, a variety of different types. We look at lane widths, how wide are the lanes approaching the intersection, number of lanes through the intersection and turning, the length of those turn lanes, and any other approach characteristics, including whether there's a sidewalk, for example. So these are the types of data that we can collect at intersections.